Good afternoon, everyone, and welcome back to the BioMedDevice Silicon Valley Center stage. I'd like to welcome you to our keynote presentation this afternoon on artificial intelligence and edge computing. I would like to introduce Srihari Yamanoor, who will be our panel moderator today, and he'll introduce you to the rest of the panelists. So we'd like to welcome you to come on down and have a listen. Srihari?
Sounds good. Is this thing, it's working. Perfect. Thanks, Laurie. So you can just call me Sri. My background has been in medical devices for a number of years, and actually, based on some advice I gave a couple of years ago in one of these panels, I've actually taken a little bit of a break. I'm working in ocean science right now, but I do fully plan to come back to devices. So it's pretty exciting for me, AI and all the new things that are happening, and with 5G finally maturing into a real thing, right? I'm sure Patrick has some opinions on that. It's pretty awesome to think about all the exciting things that can happen. So we've got Zak from Stanford. She's going to be presenting some clinical opinions and any other thoughts. Patrick's from Samsung, so the devices and the technology side, and Nanda from Oracle, which is it's going to be exciting to know about the data side as well, right? Of course, they've all done many other things, so I'll let them introduce themselves. We start with Zak.
Hi, everyone. My name is Zakia Rahman. I go by Zak, and I'm sort of the boots on the ground person. I'm a physician and a professor at Stanford, so I teach medical students and residents, and I also see patients. So, on this very esteemed panel, I'm kind of here to give a shout out and then also encourage everyone to collaborate on the things that I think need to be fixed in healthcare.
Hello, I'm Patrick. I lead the Artificial Intelligence Division at Samsung SDS, where we've gotten into medical imaging in the last couple of years. So we're analyzing the image as it comes in to try to overlay the sections that might be clinically relevant to help diagnose what diseases are there, and to try to integrate that both in the devices on the edge, as it were, as well as in the cloud as a software as a medical device.
Nandakumar, and I'm at Oracle as the head of Digitalomics. Basically, I'm a biochemist and immunologist that ended up in an IT company. And over the past 2.5 years, it's been a tremendous journey for us because I focus on the areas of life sciences, which includes pharma, medical devices, and diagnostics in terms of applications of digital technologies. Currently, I'm focusing on healthcare genomics. As you have heard, that Oracle sort of partnered with Oxford Nanopore Technologies. So the gene sequencing technologies are all applicable to healthcare genomics. And that's relevant because nowadays with EHRs, doctors are integrating the genetic data with that, and that becomes more meaningful for patients. So that's what my focus is, and I'll be talking about those things today.
It's perfect. Thank you, guys. So now I'd like to set the stage for what we're going to discuss for the next 45 minutes or so, and then we'll, of course, ask you guys to bring in some of your own questions and concerns and thoughts. Starting from Nanda, I'd like for all three of you to maybe give us one example of what you think is a low-hanging fruit. A problem in healthcare can be any problem in or surrounding healthcare that you think is kind of ripe for an AI solution, either from the technological maturity or just patient need, practitioner need, that kind of thing. So.
Yeah. One of the areas, correct, with the healthcare applications with digital technologies is this entire area of interoperability. Because you can see that with IoT, it has a lot of tremendous value both in telemedicine as well as in this area of interoperability, correct? Because if you go into any of these clinical settings, multiple devices and units are being used, and the data that's shared between all these things is very disparate, not very structured, and so on. So how do you enable that part of a communication to be much better? So that is a key area that needs to be taken into consideration in terms of enabling, streamlining all this communications that happens with different sorts of monitors that are there. So I would classify that as being one of the critical areas for low-hanging fruit myself.
Yeah, that's excellent. if we think of what is AI good for, at the moment what it's good for is to automate very specific, specialized operations that are repetitive, that are relatively easy to a human being who is trained on that task. And in healthcare, there are, of course, many of those. Actually, most of the things that can be automated this way are not visible to the patient. It's more of the back office activities that the doctor will do afterwards. During the meeting, it would be writing down the notes into the electronic medical record, which could be automated by natural language processing. After the visit, the activities done need to be coded for invoicing and billing. That could be taken care of by, again, an NLP system based on the notes that were taken. Aggregating everything into an electronic medical record that can be transported from one provider to another would be an easy solution. Having gathered all that data, you could do a lot of population-based analytics on which person has a higher risk versus another. At the moment, we can't do that because the databases are too disparate from each other. So there are a lot of low-hanging fruits which are accessible to a very simple automation, which would then free up doctors to do what they ought to be doing, is heal people.
I think I'm going to follow up on what Patrick just said. We're all gathered here, and we believe that technology one day will improve healthcare outcomes for all. But long before we'll have computers that are like us, we will be like computers. And I think that's what's happening now for our healthcare providers. We're only spending 23% of the visit interacting directly with the patients, and most of it is electronic records. I encourage all of you to read this 2016 Lancet article, "The Map is Not the Territory," that talks about electronic records, which essentially are built to maximize billing and minimize medical legal risk. So where does health fall in there? And I think that what Patrick said and the other panelists have said, these are the things that we need to work on, and if we don't work on those, we know we're not going to be improving health, not only for the patients, but those who provide care.
Perfect, thank you. I particularly like this thought that long before computers are like us, we'll be like computers. That's, it's interesting to think of how our behaviors will change as AI becomes an integral part of our life, right? If you think about how our behaviors have changed since mobile phones have been part of our life and so on, it's pretty interesting what things are going to look like. Okay, so now that we've had a little bit of warm-up, let's switch to the medical devices side of things for a bit. Thinking of medical device companies that are actually working towards implementing AI or thinking about implementing AI, some of you might be in the audience. What do you guys think are like the biggest challenges that they are facing right now, like in your background, from your backgrounds and experiences? Any of you can get started. You go ahead, yeah, please.
So apart from the obvious regulatory hurdles that were discussed earlier this morning, the challenges could be separated into two categories. One is the technical category of making the AI system work, collecting enough data for it. And in that realm, the biggest challenge is called labeling or annotation, which is the part where a human expert, a doctor, would go in and manually input their understanding, knowledge, and experience next to a particular data point. It's particularly relevant for imaging, of course, where you get the raw image in from the ultrasound, CT, MRI, whatever scanner it is, and then you would have to manually draw on it. Literally with your mouse, you would draw the outline of the brain tumor or the cancer, identify the gallstones, or draw an outline around the baby in the uterus, things like that. That takes a long time, is expensive, time-consuming, and so on. So that's definitely the biggest challenge on the technical end. And then on the non-technical side, I feel the major obstacle is change management, because making a great AI system actually isn't that hard. Getting people to use it is very difficult because they lack trust. Various companies that shall remain nameless have worked really hard to erode the trust in artificial intelligence and computer systems. So we have to build that up. We have to convince not only the management of the medical providers companies, but also the doctors, and most importantly, the patients at large, the world's population, to accept AI output as legitimate. And I think that's where the big hurdle is. So we need to find a way to reestablish that trust and get people to be happy with that output.
That's a very good point. Yeah, go ahead, please.
Yeah, the couple of areas that I've I would like to highlight in terms of echoing Patrick's sentiment is two areas. One is data sets, other is data silos. Because pertaining to data sets, it sort of follows the terminology, correct? Garbage in, garbage out. You have to get a ton of data for AI to make a meaningful decision about how things could be as the outcome of this aspect of it. So the AI is always, things are done based on using a trained, if you take like deep learning and stuff, train the systems using a known amount of data. One particular example that I can highlight from Oracle is we have been collaborating with the Ellison Institute for Transformative Medicine. They're focused on breast cancer markers. So they're looking at 3 different markers. One is the estrogen receptor, progesterone receptor, as well as the HER2 receptors. What happens is when the breast cancer...
Nanda, your mic, you want to... No, you're fine. You just want to hold it.
When the samples are sent out, correct, it's basically you're doing tissue imaging. And so when these tissue images come down and they stain with certain, H&E stains and stuff, and you look at these markers, they have come out with a methodology of doing fingerprinting using deep learning algorithms. So use a standard set of data, which in this case, they were limited to 930, 50 samples, on which they trained the neural networks. Then they applied that to clinical data set, which is about 2,500 or so from the Australian Breast Cancer Foundation. And when they did the analysis, when they looked at the clinical data, the level, the AUC as well as the ROC, the accuracy of that data was very high, comparable to traditional methods. So that is one example of saying, how the data set that is used for these things needs to be representative, it needs to be diverse, and how that can be used to train the systems. That is one particular value in this case. The other example is in data silos, because as you heard that data within the organizations could be siloed within certain groups and stuff, and they're not amenable to all the other groups. So there is a lack of collaboration and how the data is being used to make meaningful insights. One specific example where we have played a significant role is in NHS in UK, where by leveraging our data management systems, we were able to save them 1.3 billion pounds in terms of taking the data and deriving meaningful information to overcome fraud and other inaccuracies in the data and wastage and management. So those are the 2 examples that I would highlight.
Perfect. Zach?
I agree with Nanda about data interoperability. If any of you guys have gone to get your medical records, it's just basically 50 pages of stuff that you can't read or interpret. So we definitely need to have interoperability. Additionally, when we look at this data and we're teaching our machines, we have to be vigilant about our biases. We pass on these biases to these algorithms, and it is not without consequence, and it actually has some very negative consequences. So it's important that we really look at the biases, and then after the data comes out, does it pass the sniff test? Because we know what happened in 2015 when Black people were labeled as gorillas by one of the largest companies that looks at images. And that should not happen. That would not pass the sniff test. So we have to look at bias and how we're teaching our algorithms.
That's a very good point, and that's why I think human in the loop is a very important thing, right? You've got AI that can make quick judgments, especially in radiography, the imaging example you talked about, but it is very important for a practitioner, an expert, to be in the room to make sure that these machines are not running away. I remember an example based on the classic AI, the approach from the 80s. There was a CMU professor, we'll talk about all this black box stuff in a minute. He basically never put down his, I think it was a pneumonia recognition thing or something, into practice because he was scared. He didn't know how it was accurate. right? It's that explainability thing we'll touch in a minute. I also appreciate the comments on, data labeling and data silos, data integrity, that sort of thing, right? Touching back to something Patrick said a few minutes ago, there's a lot of, when we think of patients, ourselves as patients, and when we visit the clinic or hospital setting, whatever, there's a lot of stuff that happens in the background that we don't have knowledge of. But then, what about patient perception, especially towards things that they have visibility towards, right? How do we work towards improving that? So that's something that, also medical device designers themselves have to be thinking about, not just practitioners, right? So maybe Zach, you can start off.
Yeah, absolutely. We know, like what Sri said, is medicine has changed. It's a collaborative effort between the healthcare provider and the patient, and it should be that way. And so I think patients also need to be able to be empowered to make decisions. And I think oftentimes they are more confused. So we have to do a better job of having our patients trust us. And part of that is saying to patients, this is your data, you have a right to it, and we are committed to making this data usable for you. And I think at this time we have a long ways to go.
Sounds good. Anything you guys want to add?
Yeah, with regard to, the patients, correct? There was a study that was, I'm sorry. There was a study that was done by Dr. Chang et al. In which they asked the patients, what is their perception of AI? So generally they had a very positive perception of this. But at the same time, the concerns they had about this was issues relating to, say, cybersecurity, accuracy of the data, as well as lack of empathy with them. So this is where that part of education comes into play in, when the doctors give out these conclusions and results and stuff, how do the patients are able to interpret that information and make a meaningful outcome from that. So that is the thing, And I think, Sri, you mentioned about this black boxes sort of a thing, because when these, if AI is used and you derive a meaningful insight and the patient gets this information, a lot of times if there are some concerns, companies won't be able to disclose that information, how that came about. So this is where they're talking about this black boxes, as if patient questions something, is the company, willing to disclose how they arrived at that outcome. So those are things that need to be considered from a patient's standpoint.
Good point.
In terms of information that we have access to, when I go in and get a blood test done and then my medical record has a 20-syllable name and a number next to it, what do I do with this, right? I Google it. And after 5 minutes on Google, I'm dying. I have cancer or some other life-threatening disease, right? That's what happened. We've all done this, right? So what AI can bring to the table is the new research field, explainability, right? Which is to take the raw measurements that exist in the world that are objective and interpret them in a way that the human being can understand what that actually means. And in many circumstances, like blood panel, right? These numbers are not standing by themselves. There's 35 other numbers as well. And so you have a multi-dimensional data point, and you can't, Google them all in at the same time. You can Google each one separately. You will come to all sorts of really bad conclusions, and the doctor then has to unpick them for you later. So explainability, I think, can go a very long way towards helping the rest of us who don't know any medicine out in interpreting what this stuff actually means.
It's a good point. 25 years ago, there was no Google, and we were just as unhealthy or healthy back then as we are today. I like, and it's not to, you're right, you have a very important point, as funny as it might sound. It's the access to the surface level data and these search engine results and stuff. I don't want to drag all this vaccination stuff into it, but people have started believing that a couple of Google search results can make them an expert and not years of medical school training and things like that. Definitely are embarking into interesting times. So that's a good thing to kind of acknowledge when you're a patient or a practitioner or an organization that provides these back-end services, if you will. Maybe back-end's not the right word, but the technological infrastructure, right? Now let's go a little deeper on that infrastructure side of things, right? So I've said this myself before when I spoke. There's all these cliches like data is the new oil, right? And there's a statistic, and these statistics are constantly evolving. There's two aspects to it. One is 75% of all the costs that go into a machine learning application happen to be with cleaning data, labeling the data, that kind of thing. And then there's all this volume, right? I'm not a data scientist, but there's the volume, the variety, the velocity, and yada, yada, yada. So there's this immense amounts of data. Another kind of statistic to think about is maybe 5 years ago or so, we had 15 gigabytes of data being generated every month from just wearables. And the number of wearables people have has only increased. I have a Fitbit, but I also have an accelerometer on my phone. So there's all this data, right? What advice would you give to medical device companies or healthcare companies that are in the realm of collecting this data, or their patients or the practitioners that are associated with them are collecting this data? How can they improve their act, if you will, in terms of labeling, cleaning, getting it ready for machine learning applications? So I'd like to hear some different perspectives from all of you. Nanda, you want to go first?
Yeah, in terms of this data that's collecting, correct? The technologies behind it and having that diversity of data and stuff, correct? So a couple of examples I can highlight in this case is, I don't know if you're familiar with the Framingham study that was done with regard to heart risk, conditions, where it was based, the data that was used to come out to conclusions was based on one group of people, which didn't apply to the next group when they wanted to make studies. That's one example of the Framingham study. The other example is when they were using this data to make AI-based predictions on melanoma, skin cancer. They did all this test, they came back, and they were trying to apply it to the diverse set of population. This is where they found out that the study initially that was done was based on light-skinned people. When you wanted to apply the same kind of data set to dark-skinned people in predicting melanomas, it didn't work really well. So that is where you got to be very careful when you get this data. What is the representation of the population? Are you taking into the geographic diversity, socioeconomic scales, racial diversity, and so on? You need to take all those things into consideration to get a meaningful outcome or a meaningful insight at the end of the day.
If I can interject, so speaking about melanoma and data, we know that our smartphones are probably the medical device that the majority of us have, right? It's 80-some-odd% penetration in the US and 60 plus throughout the world, and we're taking all of these images, and the skin is the largest organ and the most visible. So most of the medical images are of skin. And as Nanda said, the skin cancer and melanoma diagnosis don't work in people of color because it turns out the etiology is different. So blacks and African Americans, Hispanics have much higher rates of mortality, and when their cancers are diagnosed, they're much more advanced because cancer on the palms and soles is not related to UV, it's actually related to trauma. And so when you create algorithms like the ones that were done, it of course helps the people who already have access to care, but it doesn't help those people who don't have access and actually are worse off. And I think I keep trying to go back to, if we're not improving healthcare for all, we're failing.
That's a very important statement. Yes, Patrick, go ahead.
Yeah, so the sentence, data is the new oil, I actually really love that analogy. And note, it says the new oil, not the new gasoline. So if you compare, it's $40 per barrel of oil, but $5 per gallon of gas. What happened in between there is a refinery. Oil must be refined in order to be useful. The same thing is true with data. Data as crude data is useless. You have to refine it before it becomes usable in AI systems in real life. And that's what the labeling annotation thing is for. That's what various methodologies of data cleansing are for. Throw out the outliers, the mistakes of data recording, all those data points that might have columns missing in them. There are many, many such data points that are of poor quality. and many data points that are either annotated incorrectly or not annotated at all. So the quality data has been recorded well in physical reality and annotated correctly by human experts. And after you went through those two stages, actually fairly little is left over. And that's the data refinery that we really need to go through before we can create meaningful AI systems. Then comes what I like to call hidden variables. So when we take images of people or collect numerical data points of people, typically what we don't record is, are they African American, are they from East Asia, are they male, female, or whatever. Usually that's missing because that's personal information about the individual. But with many data collections, because they're so skewed to one of these categories, this variable is present even though it has not been written down in the spreadsheet or the database, right? So it becomes what we AI people like to call a hidden variable. You can still extract that information, but it wasn't explicitly there. And that opens all the doors to the system learning a kind of racial bias or gender bias or whatever bias it is. And that, of course, will make it not work very well in real life.
Very interesting. I like the variety of perspectives here, the discussion about, hey, does the data account for race? We in fact know that even in medical devices, a lot of times the data doesn't even account for gender. It's a male-centric design. And I know a couple of the large companies are now finally making efforts to change that, right? When it comes to data, we have that challenge. We then have the challenge of, are we collecting the right amount of data, the right kind of data? Are we including, these variables that exist but have not been cleaned up, right? So I like all of your three different perspectives on this. So that should give people enough food for thought, right? One thing I'm curious, and maybe this is another thing, but do you think in the future, and I don't know how far into the future, just by looking at someone's genomics, we'd know what ethnic background they come from if, say, the data was missing? I'm still looking at this. If the data has holes in it, are there ways to patch them up? I'd like to see if you guys, yeah.
I don't know. I mean, it's funny. I mean, I can use my own personal example, correct? Hey, last year I was very curious about it. I took my sample and sent it to Ancestry.com.
Ah, right? Yes.
I mean, this is funny because I'm from the south in India. My wife is from the north, My daughter was always curious about, is there some kind of a big divide in this thing? So I sent out my sample, I came back, and I found out that I had 6% of identity towards Samoan aspects of it, and I didn't know where this came from. So I was waiting for this thing to see how it happens. Then I told my daughter, about this thing, and came back. 6 months later, they updated their database. So now that proportionality of that changed a bit. That was because when they made the conclusions on my analysis, it was based on a limited number of data that had of people of Indian origin within the Ancestry database. So the accuracy of that depends on the amount of data that they have, the number of samples and everything. So the initial predictions were very poor. As that database, more and more Indians started submitting their samples to that, the accuracy of that started increasing, correct? So this is common to a lot of these things. The quality of the outcome is dependent on both the quantity as well as the quality of the information that is submitted. That's my own personal example. The others can.
Yeah.
Let me piggyback on that. So with the same database and the same change, I changed from 33% Scandinavian to 25%. So you might consider that to be a significant change. However, am I going to do anything on the basis of that information? No, not really. It's just cute. It's a story to tell. It's nice to know, but it's not actionable. And therefore, this change or this accuracy improvement doesn't really matter. But if somebody makes a treatment choice on the basis of such numbers, then it's a very, very different story. And then we need to know how accurate these percentages are.
Good. Zach, any thoughts?
Yeah, and it almost becomes like an echo chamber, right? Of course, we want to see that whatever we've created succeeds. So people enter more information, and oftentimes, I did 23andMe, and they ask you, where is your mother from, your father, your mother's mother? And so that is just done to confirm their already existing bias in the system, instead of actually learn something to give meaningful and accurate outcomes.
It's a good point. I'm liking this discussion, right? I kind of threw it at you guys. Completely different perspective. There was a volcanic explosion in the history of the human race around what's modern Indonesia, and they did some predictions that only 75 human mothers survived. And because mitochondrial DNA doesn't alter much and passes from mother to child, it turns out they're able to say that all of us, we think of ourselves as so different, are actually not. But that said, when it comes to modern treatments and therapies and things like that, I've heard stories of the high blood pressure medication not working in African Americans as one great example. And then the counter example is they were actually able to use Iceland, where 97% of the people are of the same race, and that's when they came up with the Cas9 gene, which again, they still don't know what the racial implications of the Cas9 gene are, but they're hoping leads to therapies for high blood pressure and stuff. So we are in this like very titrated sort of data AI kind of future, and I wonder how things are going to change. We don't know. Yeah. Go ahead.
Yeah, that's one of the critical things that's happening nowadays, correct? With the healthcare decisions that are being made, the integration of genomics data with the electronic health records is becoming more and more critical, so you can make more significant insights and a much faster, decision-making stuff that goes on into that particular, area of integrating all these genomic studies. So that's where, we are working towards in our new aspects of omics.
Yeah.
And people kept asking me, what is this digital omics? Correct? And that's becoming more applicable to a lot of these sciences.
Very nice. Thank you. So now we are just over halfway of our overall allotted time. So I want to flip a little bit and ask you guys, we're talking about 5G now, right? And of course, if you look at IEEE, they're already talking about 6G because they're the guys who lay out all this for us. So maybe we start with Patrick. The question for all three of you is, what do you think, what kind of problems can we now solve that we wouldn't have been able to maybe 5 years ago? Or maybe now is not the right question. What do you think we'll be able to solve in the next 5 years that we couldn't solve 5 years ago? Kind of thing, Where do you think 5G is taking us? That's the question. Yeah.
Right. I mean, there are many problems that we will be able to solve in 5 years that we are not able to solve today. I don't know how many of those need 5G to be an essential ingredient. So, of course, what is 5G? 5G is a technical standard that allows two devices to communicate with each other with much higher bandwidth. You can transfer a lot of data in a very short amount of time. That's why you might need 5G. So 5G is great if you're a passenger in a car trying to stream a video at higher resolution. Do you need that for medical devices? It will only become relevant to medical devices if you're looking for a high data bandwidth. So it would be relevant for high resolution video processing in real time. If you have time to transmit that data, then you don't need 5G again, right? So it would have to be in real time that you need this to be done, or you have an extremely high resolution time series measurement. So that would be things like an EKG at an extremely high resolution, or a video recording at a very high resolution. So the question is, what applications are there that require these things? So we've at Samsung worked on a number of video medical imaging where you have, for example, intravascular ultrasound. This is where an ultrasound device is being put into your vein, so obviously very, very tiny. And it generates an image of the vein and the surrounding area and measures how thick the plaque deposit is and stuff like that. That video is perfectly expressive at a fairly low resolution. We've done some other applications with endoscopy, colonoscopy, where you effectively have a regular video camera, but small, inside your body. Again, it records everything, looks for cancers and things like that. Very good at a pretty low resolution. So I'm a little bit stretched to imagine an application that requires very, very high definition video or very high cadence time series. So we're going to be able to do a lot in 5 years from now, like automatically diagnose you with a wide range of diseases, primarily cancers, but a number of others. They don't necessarily need 5G, so I'm not as bullish on that, I'm afraid.
No, I think that's a very honest answer. Those are the perspectives that people need to hear too, right? There's always these problems that are looking for a solution versus these solutions that are chasing down problems. And then I was trying very hard to remember the name of the principle, but it's very similar. You know how they say, if you don't time bound something, an activity can take all the time that is available, or you give to it, right? It's a similar thing where, we constantly, images are a great example, right? And not images having to do with healthcare necessarily, but people used to be able to take photos with 5 megapixel cameras or 2 megapixel cameras. And now you have all these multi, resolution photos and things like that. Did we really need them? I don't know. So that's why I'm asking these questions. It'd be good to get your perspectives. It's good to know. So one of you?
I want to ask Patrick, because you are with Samsung, which is an international company, but why is it in the United States that we're so far behind countries like Korea? Why has our infrastructure not been able to keep up? Are we supposed to be the leaders in the world?
Something to ask our politicians. Infrastructure development is, of course, a very big problem and big task. Now, if we compare the United States to Korea, of course, the first thing to compare is simple land mass. Korea is probably the size of one of the smaller states on the East Coast. I cannot tell you exactly which state, but it's fairly compact country. The United States is far, far larger, and so the amount of cell towers for 5G or even 4G that you would have to put up in the United States is orders of magnitude greater than Korea. Then there's population density in that same space, right? In Korea, you've got a lot of people in that small country, whereas in the United States, you just don't, right? It may sound bad, but is it worth putting the infrastructure into Montana, where you have 1 million people in the size of space for a whole country or more than a country? I think those are the infrastructure problems that we have in the United States, that if you want to roll out 5G, it's going to be vastly more expensive than in a small country. And of course, we also don't have the same technological drive, because we have a lot of competing companies, or political will, because we have two political parties that are mainly trying to beat the other one rather than serve the people. So these are all sorts of problems that we need to overcome.
I agree, and Nanda, just a couple of things I'll tell you. In the year 2000 maybe, when I was still in India, one of the things I read that fascinated me was India's technological infrastructure was very poor, so poor that when the world was changing from time multiplex device access or whatever, there's TMDA, to this other technology which is CMDA, which is code multiplex. The other countries were struggling because they had infrastructure in place that needed to be retrofitted or completely broken down and built up. In India's case, they just went in and laid new infrastructure, right? So there's that example. The thing Korea is a fascinating study because it's a small country, both population-wise and landmass-wise. Also, people are highly motivated. And that does start from the government down to the people. If you look at Life's Good, LG Technologies, if you look at Samsung, these are all companies that have come out from a highly motivated population. From what I've read, and you have to take this with a pinch of salt, but even in middle-class Korean families, they have high-speed internet, high-quality television, and all the basic things too, water and electricity and all of that, completely fulfilled. Of course, if you just look north, the story is completely different. So I like these perspectives, and I agree on the political will. We shouldn't dig too deep into it. because there are strong feelings in this country, especially nowadays. So, but it plays a role too. So I'll pass this over to Nanda.
Yeah, in my opinion, where I see this gaining value is the synergy between edge computing and 5G networks. So when I'm talking about edge computing is the compute and storage that happens closer to the person, that has that wearable device, whatever it is. And with the 5G, where you see the advantages of this is, like Patrick mentioned, is the bandwidth aspects of it. There's the low latency, there's the high-speed data transmission, and 5G also improves the IoT aspects of it. Where you see these applications that will gain into the medical devices sector will be in the applications of AR and VR, where a ton of these images are being sent. One of the things where I read about this is in surgery, correct? So you have robotic surgeries and other surgeries where, let's say, a junior surgeon, maybe Zach, you can comment on this, is doing some surgery and suddenly they have something, they can connect through that particular network with a senior surgeon that could be in a totally different location to make certain conclusive decisions pertaining to that. And in that regard, one of the examples that I pulled up, even with Oracle, is that we have something called as the service and network orchestration, which in turn supports network slicing in different scenarios. And there are examples of these things that are available through companies like Oracle. I feel that there's going to be a stronger applications of this, but the question comes back to what Patrick mentioned, is the implementation of the 5G and how that can happen. It could happen in the case, maybe, one of the examples I was talking to someone was, let's say an accident happens on the highway and it's a very serious case. If the medical technicians that are there can actually transmit a lot of those information, if it's a very severe injury and stuff, to the operating room, they can prepare themselves adequately in the very specifications to solve that particular thing. Maybe Zach, you can comment on that kind of a thing.
Yeah, I agree, Nanda. So I'm a dermatologist and I teach lasers, which are my passion. But I'll tell you, every single time I'm in the room with the laser, I'm worried, am I going to go blind? Or is my resident going to go blind? Is a patient going to go blind? And so I think we have to have devices that are smart, and we have some of them, but it's really far behind. It would be great if a laser noticed movement. I mean, there are some that have optical mouse built in, so it can sense movement, so it eliminates user error. And so it allows a more equal treatment, more efficacious treatment, and then it would be great to be able to capture that image and then refine the treatment. So maybe based on the amount of melanin or pigment someone has. And if an adverse outcome comes, that data can be used and sent. So I think that those are things I would be excited, just because I think it would improve safety and probably my well-being every time I go in to do any teaching.
Sounds very good. In full disclosure, when I was a grad student at Stanford, we worked with somebody in the medical school to do haptics, to do these master-slave robots, so you could check for lesions on the skin. The remote surgeon would technically operate the master, and then the slave robot all the way across the planet would work on the lesion, and we were supposed to do diagnosis. This is 2005 I'm talking about. It really didn't go anywhere because the technological infrastructure wasn't there. The other reminder for all of us here is that one of the most prominent surgical robotics companies, I should say the one that's been successful so far, actually originally started as a DARPA project for remote surgery to be provided as an emergency option for soldiers, United States soldiers, Army, Navy, Air Force, whatever you want to call, to be treated remotely. Funnily enough, the company is very successful. That project is, or I shouldn't say project, but that kind of a solution is finally maybe about to take off. But again, the question is how many applications? So I see some good, maybe conflict is a too strong a word maybe, but different perspectives, right? Do we really need it? Versus, hey, maybe we need it for road accidents and the military applications and things like that, or neonatal care in Africa. I don't know. There are so many places where care hasn't seeped into, and then maybe these things have some potential. But I also like Patrick's point. This is the same thing. It goes back to, hey, we were all either as healthy as we were or as unhealthy as we were before Google told us we were going to die in 5 days, right? So a low resolution camera output maybe is enough for most of these situations. So maybe we are looking at a highly narrow set of applications where 5G has influence. And then we're also looking at the corollary where you now have 5G, so maybe you're just going to do things faster, right? Or fill up all the network bandwidth with something. So these are all interesting perspectives. In a couple of minutes, I'd like to turn this over to the audience. Just wanted to ask you guys one last question. Let's try to see if we can do this as a lightning round, but I'll let you guys decide. Healthcare costs in the United States, right? Even more than infrastructure and all of that. Everybody has an opinion on healthcare costs. But let's see, which is good, you know. Is there something AI can do that you guys think can help us optimize? I don't want to be bold enough to say reduce, optimize healthcare costs, or at least understand where some of that is coming from. So I'll turn it over to you guys.
At least from my side, from whatever that I've learned, where AI and other technologies can help with, cutting down on those costs, the areas are in the areas of diagnosis and treatment, in surgery. They're using effectively natural language processing in that aspect. There's this other aspects of nurse scheduling, where AI can be used very effectively in that case. And there's also, I've heard about robotic nurse assistants that can deliver all these tools that are needed during surgical process. And the last thing is at UCSF, they have a robotic pharmacy that can actually deliver medications and stuff. So in my case, I'll conclude that by saying that one of the examples that we have from Oracle itself is there is a biotech company called Elam Biotech, which is using basically virtual humans for clinical trials because they were doing case studies with heart. So they can go back and look at that images, and if I'm treating with a drug, how will the heart respond? For which they were able to do virtual, analysis of all those things, which in turn saves a lot of time and money, and you don't have those patients available and stuff. Where Oracle came in and offered all the cloud computing, Oracle cloud infrastructure, as well as the high performance computing to enable that to happen. So there's a perfect example as to how this technology can be leveraged to cut down costs.
Perfect, thank you. Either of you?
Yeah, so AI has, in general, three main value propositions or financial relevance. So first of all, there's automation, of course. AI can do stuff that a human being can do, and it's repetitive and easy, and thereby free up the person to do something else, making things cheaper. The second value is in enabling new business models, right? We're all customers of new business models that didn't used to exist a few years ago, and they're based on artificial intelligence. And I'm talking about Netflix and Uber and such things, but they're going to be available for healthcare as well. The most important and third benefit of AI in any industry is increasing accuracy, right? And in healthcare, it will increase the positive outcomes. It will provide you feedback instantly, as opposed to you having to wait days or weeks for it. Thereby, you can start treatment earlier. Misdiagnoses, wrong diagnoses will go way down. AI will be very accurate to tell you what you've actually got so that you can target the treatment. We can access precision medicine only through AI. We cannot do precision medicine with any other technology than AI because that's the only technology that automatically identifies for the specific human being what is relevant to them. So we will see the costs go down. Yes, reduce, Sri. We will see the costs go down, first of all, because we will need less person hours per individual patient in order to diagnose and treat them. And we will treat them better, which means that all the making up for the mistakes we made earlier, all those costs will go way down.
Perfect, thank you.
Yeah, I think exactly what Nanda and Patrick said. We have to realign incentives, right? Because right now, healthcare costs, they double every 14 years, and our outcomes are among some of the worst in industrialized nations. And so we have to realign those not for profit or medical legal risk, but for improved healthcare outcomes. And I think the more we realign those incentives, the lower the cost will be and the greater the accuracy.
Thank you. I like the idea of realigning incentives, and it's kind of scary that healthcare costs double every 14 years, but that's one of our challenges. And I also like the very important reminder that precision medicine does need AI. It was better to have you say healthcare costs can actually be reduced rather than me make that and Nanda's perspective.
So that's also one of the things that's coming into play in terms of the trends in this is the value-based cost, correct?
Yes, value-based care, yeah.
So a lot of companies, when they have these medical devices, they're designing the pricing of those devices is based on the outcome derived by the patients. So there's a change in that pricing models that's happening with several medical devices. So you have to take into consideration of that value-based costing systems.
Yeah, perfect. So let's try this. I'd love for you guys to ask these experts some questions. So we turn this over to you. Laurie has the mic if anybody has questions.
Hi, thanks. That was a really interesting discussion. I'd like to go back to your comments about the Ancestry.com results changing as more information comes in. Obviously, that's a very low-risk example. But for more high-risk examples, do you feel like we should be holding back until we have better uncertainty quantification? Or do you think we're at a point where actually we have these tools, we just need to be applying them and using them?
I think, at least in my opinion, it's a gradual evolution, correct? Right now, when you start out this process, the data sets are always limited. So when the data sets are limited, you come out with some outcomes and see where those outcomes are leading to. As the data sets increase, the outcome itself becomes more meaningful. So it's what I call as the necessary evil of this thing, where you have to start out something, play with it, find out where the errors are, and then keep improving on it. So I would go with that, even though that was more towards a consumable, genetics area that I highlighted, but that applies to all other areas. As the more populations come in, and there's more screenings, more genetic tests are available, this becomes meaningful in that case,
Yeah, exactly what Nanda said. But to add to that, the company making the model needs to document exactly what data they used. As an example, the facial recognition systems that got bad press in recent couple of years, they were made on Caucasian faces like mine. And if you use them on Caucasian faces, they work just fine. But if you use them on people who are not from the same ethnic background, they don't work very well. Of course they don't, because they weren't trained on them. Right? So if that was appropriately documented and only used in that circumstance, the systems would be okay. It's the same thing for this healthcare. You need to see which area of the data set are they relevant to, and then only use them for that.
And information is not knowledge. Those are completely different things. We know with this pandemic, we are inundated with information every day. Makes us all afraid and more anxious. But it's not knowledge, and it certainly hasn't improved kind of the state of the pandemic. So I always say, don't mistake information for knowledge.
I highlight with one other example that's very critical to what you talked about. I had a friend of mine who went to see his kidney specialist. And he came back and literally crying because he said, my doctor classified me under CKD4, chronic kidney disease, stage 4, correct? So went back and asked him to get a second opinion. So he went to another doctor who was of Asian origin. And they lowered his CKD level classification because the original doctor was Caucasian, was looking at the data that he had based on the proportion of Caucasian population. According to that, this patient was classified as CKD4. But if you take his own ethnic thing, it was a lower level classification. Now you see, if they had treated this person, how dangerous the situation could have been. So this, again, relates to the thing that you asked about, this data sets, correct? Whenever those conclusions are being made, look at the right data sets and the volume. As the proportion of that population and diversity increases in a society, that level changes.
Right. That's perfect. Any other questions?
Thank you. This is really interesting discussion there. So I have a specific question for Patrick. You're talking about in 5 years, there will be a little camera getting into the whole body and to tell specifically for a cancer if it's possible. So that is really going to be generate tons of information. And I also understand what the dermatologist is saying, the knowledge, information is not knowledge. So my question, I guess, is at that point, if I am a person, I'm not having cancer, I don't have symptoms, but if I have a history of family, everybody has it, then I go there to request to say, can you use that little camera, go through my body? Now, is the medical community would say, oh, this is legitimate, you have this and that is suspicious, and go. Would that be, at that point, that the knowledge and the information can be coming a one and provide some useful information for my decision making? What should I do from there?
Yes, in brief. So there are certain camera video technologies that you can do this afternoon. You can do an endoscopy, you can do a colonoscopy. These are examples where a video camera is being put into your body. It results in a video recording. You can do intravascular ultrasound, like I mentioned again, a video of the inside of your body. These are technologies that are in existence right now. You can go and get that done immediately. The only difference between now and in 5 years is that right now a human being will look at that video and analyze whatever your insides look like. In 5 years, it won't be a human being anymore. Now, the major reason for that is that each one of these three things, endoscopy, colonoscopy, intravascular ultrasound, they all result in about a half-hour, 45-minute video. And if you have a disease like a cancer, it will show up in maybe 10 or 15 frames. So in less than a half a second worth of that 45-minute video. So not only does a doctor have to watch the video, they're going to have to watch it very carefully, right? And occasionally rewind to make sure, did I miss the odd spot, right? So in other words, it takes hours for a very qualified physician to review that video footage. And that's what makes the thing expensive, right? So if you go in as a healthy individual, to get that done, you're going to have to pay for it yourself, and that's going to be quite pricey. In the future, if the AI simply reviews the video, picks out the correct 15 frames, shows them to an expert, and that expert says, oh, yeah, cancer, the price will go down by, I don't know, 80%. That's what makes the difference, and therefore a lot more people can be videographed like that, because a single doctor can go through many, many more videos. Ultimately, I'm completely with you in the sense that I think the current system that we have is actually sick care, right? It takes care of sicknesses. What I'd love to get towards, what I really want, my vision is health care. I would like the system to take care of my health, and rather than try to, take my sickness away, is preserve my health. And so I would like to go into the hospital as a perfectly healthy person and ask, what can I do to stay this way, right? And that's what you're getting, and I love that. Right now we can't do that, it's too pricey, but I hope in a few years we'll be able to do that.
Awesome. Do you think we have time for one more question? Okay, does anyone have one more question they'd like to ask? Yes, please.
Is it on? Oh, there we go. So I came in kind of late, so I'm not sure if you guys went over biases.
We did. Zach pointed to them. Go ahead, please.
So what I was wondering is, obviously we have biases that we find out as we're developing the AI, but then there's, we don't know what we don't know. And some of the devices that have come out, after it's already been, released to the FDA, it's like, oh, well, for skin measurements with people that have darker skin, oh, it's not as accurate because we didn't have the right data. So is there any way with AI to take models and start building in or looking for biases? I mean, obviously you can't look for what you don't know, but is there a way of doing that? And are companies doing that right now, trying to be more broad, do kind of models to see, oh, is there a statistics we can do that shows what kind of biases might already exist by looking at the data set?
Right. I think there's some sound opinions, and I have something to add too. So I'll let the three of you speak first, and then be a nice way to conclude the thing as well. So go ahead, please. Patrick, let's start with you then.
So I'll start. Yes, we are looking at bias, and everybody else is looking at bias too. it comes back to that thing about hidden variables that I mentioned earlier, right? You generally don't have this information present in the data sets, which is a double-edged sword. First of all, yes, you're not learning it, which is good, but then you also can't check whether you are or are not biased, which is bad, right? So you actually need to make it explicit. You need to record that information in the data set, and you need to not give it to the AI algorithm, but you need, as a human being or as a company, need to retain the information and then check. And in fact, we are doing that. We as Samsung are doing that, and a lot of our colleagues in other companies are doing that as well, to prove that we are not biased. The problem is, though, that we can only prove we are unbiased against the couple of categories that we do record, right? So we can say, okay, we can resolve the ethnic problem or the gender bias, right? But now comes the next part. Right, what about this category, that category, right? Are we suddenly biased against a certain age group or against a certain group that has this gene versus that other gene, right? How many of these hidden variables are there? There's going to be a limitation. So bear with us over the next 15, 20 years maybe as we figure out which these hidden variables are and how to record them. Certainly in history, last few years, a lot of these biases came to the forefront, and we're trying to eradicate them.
Zach?
I mean, I said Patrick because he's the one solving these problems, but you're right, is the implicit or unconscious biases. They're the ones probably hurting us the most. And, you know, we see this, certainly in my field, you see people who are more attractive are considered more likely to be innocent in jury trials, considered to be getting higher grades as teachers. So it really seeps down to every level of society. But it is, how do we know what we don't know? And so we're dependent on the other bright minds on this panel to help solve that.
I think one of the areas where you can get started with that is by using real-world evidence that's available right now to sort of start tackling that right now. And like Patrick said, it's going to take some time, but what can we do now with what is available? So going towards real-world evidences could help sort of expose what those biases are and how that can be solved.
Yeah. So just to scope out how challenging the problem is, there are over 20 types of scientifically recognized biases, and all of them start from us. I'll give you one more example of how complicated that gets. I like your example of these juries, not to blame people in juries, but human beings make a decision on meeting a new human being by looking at their face. Right? That's our main data source. For people who are not blind, of course, it takes less than 7 seconds to make a judgment. And then it takes a really long time before that judgment changes. Right? So that's the scope of problem. And I think earlier in the presentation, Zach mentioned our biases tend to go into both our algorithms and into our data. Right? This also goes back to another example I mentioned of this scientist at CMU who shut down his own excellently working application because he had no idea how it was making the judgment calls. So that's kind of the scope of the problem, and I think 15 to 20 years is probably where it'll be. One last comment is the FDA in the United States is very interested in AI. They're asking for several public commentaries on things like this, so software as medical devices. We didn't have a chance to touch on that, but also as AI, how AI is being used and things like that. They're constantly approving algorithms, especially in the radiography space. So there's a lot to be concerned about. I think the panel might be here for a few more minutes if anybody has questions. And I wanted to personally thank both the audience and you guys for being here today and answering all my questions. It's been a very fruitful and great learning experience for me. So thanks all of you. Thank you.
Thanks,
Thank you, everyone.
Thank you.
Thank you.